Hey everybody, welcome to Chapter 1, Section 1, Points, Lines, and Planes. In this section, we're going to go over the most basic or fundamental definitions for the subject of geometry. So let's first start off with the definition for a point. A point is simply supposed to represent a location. It has no shape or no size, and it's going to be named by a capital letter. So I could say, hey, this is point A. That's it. All right. A line can be made up of two or more points, and it has no thickness or width. That's not really relevant, okay? A line will be named by letters of two of the points on that line, any 2 points. So if you had like 10 points on a line, you could choose any two of those 10 points on that line to name that line. You might also see a lowercase script letter naming a line. So here's what I mean. In this example, I can call it line M because there's a little M here naming this line. It's not naming a point because it's not by a point, and also it's lowercase. Um, and then I could call this line PQ or QP. The order doesn't matter. So yeah, if you say PQ but your neighbor says QP, you're both talking about the same thing. All right. And then a plane is a flat surface made up of at least 3 points not on the same line. So think of a plane as your basic two-dimensional shapes. Um, Triangles, rectangles, squares, hexagon, octagon, rhombus. All those are different examples of planes because they have at least 3 points that are not on the same line. So it can be named by a capital letter or 3 points not on that line. So this example, you have um, you have a rhombus here, I guess, and then you have these 3 points somewhere in the plane. They're not on the same line, and you could call it BCD, DBC, CDB, or you could call it plane K because this K here is meant to uh, denote the plane here. It's not by a point. You see there's no dot by it. All right. So once again, order doesn't matter just as long as you're using three non-connected points. Okay. It's some more vocabulary. If you have points that are connected, then they're collinear points. Okay, they lie on the same line. If they're not connected, then they're non-collinear. All right. And then if you have points that exist in the same plane, then they're considered coplanar. And if you have any points that are outside that plane, then they're non-coplanar. So here I have a plane, and I want you to name a line containing point W. So you have some options here. You could call it line N, you could call it VW or WV, VX or XV, VY or YV, XW, XV, XY, you have a lot of options is what I'm trying to get at. And so I think I wrote all of them down, but yeah, as long as you use any 2 points on that line, you're good. Now let's name the plane containing point X. So the only thing that you cannot use to name the plane is you can't use the lowercase letters naming the lines. Um, and you can't use the T that's outside of the plane. So you could use any three non-connected points. Now, obviously, most of the points are connected on this line, so you can use two of these points, and then you have to use Z. So X, Y, Z, W, X, Z, V, W, Z, V, Y, Z, or you could just call it plain P, because that's what that P is there for. All right. So again, there's a bunch of answers just as long as you use any three non-collinear points and they're coplanar, I guess. And then I ask, is VW the same thing as WWV? Yes, they are. It's just you're just flipping the order, and order doesn't matter. So if you know they're collinear, then yeah, they're the same thing. Example 2 from example 1, that picture. Name all the points collinear to W. Well, that's easy. That's V, X, and Y. That's it. So it would just be like, don't say T or Z, because those are the only points non-collinear to it. Speaking of non-collinear to the W, points T and Z are not. Example 3, use this figure to name each of the following. So a line containing point R, you see that R is on two different lines. R can be on line M or RY or RX, or R is also on line RZ or line L. So that's what I listed. Um, if you forgot your cursive, that's a cursive L, and then that's an L, not a 1. So yeah. Um, Moving on to B, a plane containing point X. All right, well, point X is inside the plane, so I could use any three non-collinear points. So I could use X, Y, and then I have to say W. I could say XR, and then I have to say W. I could say R, W, Y. I could say R, Y, W. Um, you don't have to have X necessarily in the title. You could also say plane B. So there's some. Um, Now I'm going to use the figure to answer these questions. What geometric figure is named by each singular letter? So I'm not asking about what shape is this. Each singular letter represents a point. Why are two letters used to name a line that models the maroon border on the card? Because you need at least 2 points to draw a line. And then I wrote they're collinear. Because if you're connecting a line, if you're connecting 2 points, then they now become collinear. So I got a couple other definitions to add in. The intersection of two lines happens at a point, and then the intersection of two planes happens at a line. So if you think about it, if you draw two lines, yeah, they touch at a point. And if you think about two planes, just picture like a cube. All those walls of the cube, the faces, they all touch each other at the edges. Each edge is a line. So, and each face is a plane. So every time the faces meet, they form an edge or a line. So uh, planes intersect at lines, and lines intersect at points. And so this example is kind of weird, so I'm just going to skip ahead to the picture. I would be giving you instructions to draw and label a figure. So I would draw lines A, B, and C, D, and then they'd have an intersection at point E. So here are all the coordinates. Remember, graphing a line, or graphing dots, or points, I should say, it's X comma Y. So X is -2, Y is 4, so I'll go left 2, and then up 4. 0 is X, -2 is Y, so I won't move left or right, I'll just go down 2. And then -3, 0, left 3, don't go up or down at all, and then 3, 3, right 3, up 3. And then if you were to connect the dots, or connect the points, I should say, point E should be roughly at -1, +1. And then the additional instructions are to draw and label a point that is coplanar, meaning somewhere on this graph, or the grid, it's coplanar with all these points, but not collinear. So point F can be anywhere in this white space, just nowhere on the blue lines, okay? And then draw a line, so it's separate from this, line QR that intersects a plane T at point S. So that sounds real confusing, but it's real simple once you look at a picture and you think about it backwards. So if I have plane T and I have a line going through it, imagine you're stabbing a pencil through a sheet of paper, okay? So line QR is the pencil, and it intersects with the paper at point S, and the sheet of paper is obviously plane T. So I think it makes sense going that way. Um, all right, so here I have this picture. How many planes appear in this figure? Well, first we have this pyramid, and pyramids are named by their bases. So you see this has five sides. So that's a hexagon, or pentagon, sorry. So this is a pentagonal pyramid. And then it's laying on top of a plane X here. So it's sharing a bottom. So in other words, it's got 6 sides, or 6 planes. And then if I were to name each of them, well, the bottom would be plane X, and then all these other sides, you could call them, H, D, G, G, D, F, J, D, H, J, D, E. I think I covered all of them. And then you could also call plane X something else like H, G, F, or E, F, G, or E, J, H. Any of these bottom points, you could use L, F, L, G. Any of these points on plane X could be used to also name plane X. So, there's often a lot of answers for these types of questions. So name 3 points that are collinear. Well, if you look, D, K, and J are collinear. Name the intersection of plane HDG with plane X. HDG, and then plane X. So they're touching right here at HG. This is a plane, this triangular face, and this is a plane. So they're intersecting at the bottom, line HG. At what point do LM and EF intersect? So LM's here, going off of the plane, and EF is right there. So they don't even touch, so they must not intersect. So it's kind of a trick question. And then does line LM intersect plane HGF? Well, here's LM, and then HGF, that's another name for plane X. So does it intersect? Yes, it does, because again, if this were a pencil, it'd be touching at point L. All right. And that's going to wrap it up for the notes. So if you enjoyed this, hit that like button. And if you feel like you learned something, hit that subscribe button. If you feel like it, no pressure. But yeah, thanks for watching and goodbye.